I'm here to talk about Schrödinger, Heisenberg, and this guy. But before I can talk about them, we need a little bit of background. The scientist before these guys was Bohr. His model only worked for the hydrogen atom. He said that you can find the position of an electron, which defies Heisenberg's model, and he said that electrons have a fixed circular orbits, which defies classical mechanical physics. So that's when these guys come in, not too long after. First, this guy basically says that electrons are both like particles and waves. To explain this, let's look at an electron. It's here, it's a ball, and it's an object. It's a particle. But let's look at a wave. The wave has peaks and lands, making an up and down motion. Waves have frequency and wavelength. Frequency being how many times the line comes up and down, and wavelength is how much distance is between any given peak and land. Now, let's relate the electron and the wave. Let's get them down together. Now we can see that the electron is on an invisible circle, so to say, and it spins around on it. And the electron can jump around on these lines depending on if it has been energized. So let's say that this is just a stable state. The electron is at its native charge and its native level. Also notice that the electron circles the nucleus at a certain speed. Let's call this the frequency. Now let's make the electron unstable and energize it. Now the electron is unstable and has move energy levels. Notice that it now circles slower and it also has more energy. This is an inverse relationship, the same kind of relationship that we see in the line's wavelength. Let's call the energy the wavelength. This supports the theory that electrons have a particle and wave duality. Now let's look at what Heisenberg had to say. Heisenberg basically proved that we cannot know the exact position of particles at any given time based on the fact that in order for us as humans to see something, we require light, which in itself consists of particles. And if we have particles colliding with other particles, there will be movement and will cause an inaccurate reading. So let's visually do this. This one is a photon, a particle of light, and this one is an electron, a negatively charged particle. Now, in order for us to see the electron, the photon has to bounce off of the electron to return the image to our eyes. So if we wanted to see it, it would have to work like this. But unfortunately, it doesn't. It works like this. Now we have the image, but the electron is no longer at that spot by the time that we have the image. Understand? Now the last guy, Schrödinger. This guy made an equation to predict and calculate energy of atoms as the electrons move around, essentially giving us an accurate visual representation of the atom. Let's take a look at what I'm talking about. Looks funny, doesn't it? This is because it came up with the concept of instead of the electron being on a track, it's in the vicinity of a given area. These are the energy levels. So Schrödinger's diagrams give us an approximate guess as to where the electron is going to be found, giving us a good representation of what the elements look like. Schrödinger also conducted an experiment with a cat that supports Heisenberg's idea of uncertainty. Schrödinger placed his cat in an opaque box, a box that you can't see through, and slowly pumped poison into the box. Now because the box is opaque, we have no visual confirmation that the cat is dead, but we do know, however, that the cat was alive at some point. So in essence, the cat is both alive and dead at the same time due to uncertainty.